All right, today's lesson is on a new method of factoring. It's called factor by grouping. These are not in Google Classroom. You just write them down by hand. I'll go ahead and show you the steps. You can pause and write these down, or you can try and keep up. Number one, we want to group pairs with the GCF, and we want to factor out the GCF, write the new GCF in a new set of parentheses, multiply by the remaining terms, and then check to see if it can be factored some more. Again, you can pause and write those down, and I'll go over those step by step so it will make more sense as we're doing a problem. But it's one thing to look for when you're solving, or not solving, but factoring by grouping, is the ones I'm going to give you are going to have four terms. Okay? They have four terms, and this is not a quadratic, this is a cubic. Remember, you just learned classifying. This would be a cubic polynomial of four terms. And something I forgot to mention, this 2 in front of the highest exponent term is called your leading coefficient. So my leading coefficient is 2. So step number one, group pairs with the GCF. These first two have a GCF. I'm going to group them together. Sometimes it's the first and the second, sometimes it's the first and the third, sometimes it might be the first and the last. I'm going to group the last two together. Okay, so that's what I mean by group them in pairs that have a GCF. Sometimes the GCF is 1, and we'll see one of those in a minute. Okay, step 2, factor out the GCF in each set of parentheses. The GCF on this one, they both have a p squared. And if I take out the p squared, I'm left with 2p. P squared times 2p is 2p to the third, plus 5. Because p squared times 5 is 5p squared. Here, the common factor, the GCF, is just a 3. But notice what happens when I do that. What's left in the parentheses are the same, 2p plus 5. Okay, so step 2, factor out the GCF I did. Write the new GCF in parentheses. Notice they both have a 2p plus 5. That's a GCF. Just happens to be a binomial. So I take out the GCF again, multiply by what's remaining. The terms remaining are p squared plus 3. So that is factored. Now this check here is just to see, can you factor any of these? That doesn't have a GCF, that's a perfect square, but that's not. So that cannot be factored anymore. That problem is done. Problem number 2. Again, you can pause, you can rewind, and then look at these notes or follow these steps here. So step 1, group pairs with the GCF. I'm going to group, I always check to see if I can group the first two. It's not always the case, but in this case it is. And I like to keep the order the same, positive, negative. And this is positive, negative. I'm going to show you what I mean by that in a minute. Might have to do something different on another problem. So I'm just grouping pairs together. Step 2, factor out the GCF. These two only have an n squared as a common factor. So I'm left with 3n minus 4. Common factor on the second set is just a 3. Again, I'm left with a 3n minus 4. That's my new GCF because they both have a 3n minus 4. So I write the 3n minus 4 out front. It's sort of like I just took that away from here and here. What's left? I have an n squared plus 3. So multiply by n squared plus 3. And if you FOILed that out, you would get the original problem. If you want to try one of these on your own, you can pause and then check my work with yours. It's a very similar problem. I'm going to group the first two together. I'm going to group the last two together. And notice the first and the third have something in common. I could have grouped those two together. The second and the last have something in common. I could have grouped them together. Common factor here is 3n squared. So I'm left with 4. Oops. I think that was supposed to be an a. So the common factor is 3a squared. And I'm left with 4a minus 3. Just double check to make sure if you distribute that, you get back to those two. But on this one, they have something in common, but it's just a 1. Okay, they have a common factor of 1. And notice again, I have in both terms a 4a minus 3. That's my common factor. So I write down my common factor and I multiply by the remaining terms. So it'd be 3a squared plus 1. All right, 2 more to go. This isn't the hardest factoring. It's just got to practice. Okay, so on this one, here's this one I want you to watch for. If I group the first two together, notice that I have a positive, then a negative. And I want the same thing here. I want positive, then negative. What I just did is I have the opposite of that. So I'm going to go ahead and factor out a negative there. And I could have done that on the next step, but notice positive, negative, positive, negative. If I distribute the negative, I get right back to where it was. Common factor here is 5x. So we're left with 7y minus 1. Well, for this to work, this should be 7y minus 1. Well, the only way to get that is to factor out an 8. 8 times 7 is 56. So yes, that works. Then I have a common factor of 7y minus 1. And what's left, I multiply by 5x minus 8. And I check, can you factor any of those? No GCF, no difference of squares, no difference or sum of cubes. So that's good. I'm going to try another, there's another special one. But if you want to try it, put it on pause and go ahead and try it. So again, I'm going to group the first two. Sometimes that doesn't work, but notice positive, positive. The only way I'm going to get positive, positive out of here is if I factor out the negative. Distribute the negative, I would get minus 6x minus 3, so that works. Common factor here, 4x squared. Now I'm left with 2x plus 1. Common factor here is a 3. And again, I'm left with 2x plus 1. 2x plus 1 is common to both terms. I can factor that out, 2x plus 1. And then I multiply by what's left, 4x squared minus 3. Now, I was thinking maybe this could be factored more, but the 3 is not a perfect square. If that was a 1 or a 9, then that would be a difference of squares. So this is now factored completely. And you can FOIL that out to see you would get the original back. So this is just another method of factoring. It's called factor by grouping. Now, on the homework, I'm going to just show you this. Some of you aren't going to be happy if you don't get credit. Here's the assignment, and I cut off the title of this and the page just so some of you couldn't find it on the internet. Here are the 14 problems. You are not doing any of them on this side. On the other side, all this room, you're going to write down problem number 1 here, and you're going to do the work here, and you're only submitting this side. That's the work from this assignment. Okay, so problem 1 goes here. There's 15 boxes, but there's only 14 problems. Guess what? There'll be one empty. You can draw a picture for me. All right, there's your assignment. Good luck.